Hello everyone. So we are here with the next topic, that is Grasshofs Law and universal join. Okay. So moving on to it. So what is Grasshofs Law? Okay. So Grasshofs Law is applied for 4-bar chain mechanism for having a mechanical advantage. Sole purpose of any mechanism. Okay. So the sole purpose of any mechanism is to have a mechanical advantage of its mechanism. Okay, so we use different inversion according to stationary or fixed link which help the stated law. Okay, so this law gives different mechanisms which have evaluated for today's big machines. The sum of shortest and longest link should be less than the remaining two sides. So here you can see this formula: S plus L is less than equal to P plus Q, where this S is the shortest link, okay, L is the longest link, and this P and Q are the remaining links. Okay, so mechanism desired here is the desired output with mechanical advantages. This one. Inversion, when we obtain different mechanism with same link and joins by changing fixed link, that is fixed link is necessary for practical use mechanisms. Okay, here you can see these figures. Here you can see these figures where the first one is the continuous motion, this is the drag link, this is for the crank rocker, this is for the double rocker, and this one is the parallelogram linkage. Okay, so here you can see in the drag link, here the equation will be S plus L is less than P plus Q. Okay, so in crank rocker also it will be S plus L less than P plus Q, but in double rocker mechanism the equation will be S plus L is greater than P plus Q, and for parallelogram linkage it will be S plus L is equal to P plus Q. Okay, so moving on to the advantages of Grasshofs law. So as per Grasshofs law, if 4-bar link follows the equation, so there will be two cases. Number one, that is S plus L is less than P plus Q into S plus L is less than P plus Q. Okay, so here we have option to fix any of the S, L, P and Q. Okay, so any of the links with if we name the links as S, L, P and Q, so we can have the option to fix any of the links between these 4 links. Okay, now here you can see if S is fixed, then we will get complete rotary motion on input link and output link, which helps in machining of workpiece with planar machine, Whitworth quick return mechanism. Okay, so nowadays they are not in use because of advanced mechanism, crank slotted lever mechanism. In aircraft they were using this mechanism to get propulsion with 7 to 9 cylinder. Okay, so here you can see a note: for people with non-technical background, your fixed link drives input and output. We measure difference with respect to a reference, and that must be stationary in mechanism. That's why we always fix one link. Okay, so this is why we always fix one link at a time. Okay, next, if S is adjacent to any of the fixed link, that is any of L, P and Q, okay, any of the 3 links, then in this case we are 100% sure that we will get one rotary motion and one reciprocating. Okay, so but it is depend on its position whether it is on input link or output link. Okay, next, if S is on input link, then we will get oil extraction machine, L fixed. If CR is fixed, then we can make shaper machine, improve quick return mechanism. Okay, next, if S is on output link, then we will get sewing machine. If S is as a couple link between input link and output link, then we will get a double rocker mechanism. Example, you can say the wipers in cars are made from this mechanism. Okay, point number 2, that is L plus S plus L is equal to P plus Q. S plus L is equal to P plus Q. Okay, so in this case, if parallelogram can be made means S S L L, then whether we fix S or L, we will get double crank motion, which were used in diesel locomotive engine. Okay, so in parallelogram what happens? Both the opposite sides are equal. So if we fix SS and LL, okay, then whether we fix S or L, we are going to get a double crank motion. Okay, so if it is anti-parallelogram, then the case will be same as above mentioned in previous point. Okay, next, Grasshofs law is giving choice of mechanism and which are being modified to obtain suitable efficiency. Next, moving on to the universal joint. So what is now a universal joint? Okay, so a universal joint is a mechanical device that allows one or more rotating shafts to be linked together, allowing the transmission of torque and rotary motion. Okay, it also allows for transmission of power between 2 points that are not in line with each other. Universal joints come in a wide variety of shapes, sizes and configurations to accommodate the infinite amount of applications they can go into. You should always consult a professional before selecting a universal joint. Okay, so next, universal joints allow drive shafts to move up and down with the suspension while the shaft is moving, so power can be transmitted when the drive shaft isn't in a straight line between the transmission and drive wheels. So here you can see universal joints of automobile. So first is the universal joint, next basic types of universal joints, cross type joint, next speed variation of a hook type joint due to drive and driven shaft inclination, next double hooks type CV joint, next is the tractor constant velocity joint, next is the JEPA joint, next is the curl width constant velocity joint, and the last is the tripod type CV joint. Okay, so with this we have come to the end of this lecture. Thank you everyone.